Welcome back. In this video, I'm going to go over all that we've done so far. We'll put it all together in another example. We're going to review here the hotel satisfaction study. A little background about this hotel satisfaction study. This is the kind of data that one would see often with service industry, where they are constantly interested in figuring out how they can improve their service. One way to do so is to glean or gather satisfaction data from their customers. In this particular data set, we have satisfaction measures about a number of different aspects of the hotel experience. These include satisfaction with aspects such as the dining experience or the room cleanliness and so on. And we also have an overall satisfaction measure. Finally, we also have data on individual customers. Specifically, we know about how far they traveled to get to the hotel, how many nights they stayed, the purpose of their visit, the average amount spent on the room, the food, and the Wi-Fi. We also know the elite status of the customers. Are they platinum, gold, silver, or do they not have a status in the customer database? Let's take a look at the data set first before we proceed forward. The dataset we're going to look at is in the file called hotelsatisfaction.sav, and here it is. In this dataset, you can see we have a spreadsheet containing a number of satisfaction variables, followed by a couple of variables about customer data. In the variable view, you can see more information about these variables, including their a more detailed label for every single variable. All right, so let's take a look at, let's review some of the variables. On top, you have a number of variables, including satisfaction with the experience. So we have your satisfaction with how clean the room was, how clean the bath was, how clean the common area was, satisfaction with the front desk staff, dining staff, house staff, valet staff. The perks program, the prices of the room, dining area or the dining experience, Wi-Fi, parking, and so on. We also have information about satisfaction with the location of the hotel, how close it is to transportation, events, and hotel hotel points program, as well as satisfaction with the recognition program. Then we have an overall satisfaction measure. And we also have some data on things like the distance traveled to get to the hotel, nights stayed, the purpose of the visit, average spend per night on room, food, Wi-Fi, and finally lead status. Now, some of these variables that we have are numeric, and some are not numeric. For instance, our data on visit purpose is a string, so is elite status. And these are scaled as being nominal. The rest are all interval scaled or ratio scaled. Okay, so anytime you've got a variable that is nominal scaled, you typically cannot utilize that in its native form in a regression type model. Considering a variable like the state somebody lives in, if you were to code different states being 1 through 50, the number for the serial number for a state wouldn't signify the importance or relevance of the state. It would merely be a unique identifier. Using this unique identifier as a scale variable would be incorrect, because then whatever state is labeled as number 50 would be seen as being somehow better than the first in the alphabetical order for the states. Okay, so in our case, we have two variables to be concerned about: string elite status and visit purpose. These can't be used in the native form in regression. They'll have to be modified. Specifically, they'll have to be dummy coded. process of dummy coding involves taking a variable that has k levels and converting them into k-1 dummy variables. Let's examine elite status to see how many levels it has. So we'll construct a simple table out of elite status and take a look at how many categories there are for elite status. So in our data, in this analysis, we have here gold, no status, platinum, silver. Second, let me create a fresh output file that we can use. Pardon me for that delay. So here's our, we have a fresh output file out here. It shows us that the levels of elite status are gold, no status, platinum, and silver. And shows us the percentage of response in every category. Now here we have a total of 4 levels of the variable. In order to use this in a regression, we would need to dummy code this. The dummy coding process involves converting k levels into k-1 dummies. Let's do that. To create a dummy variable, you'll go to let's go to our spreadsheet view. You can go to transform and select from here recode into different variables. We know our variable we want to modify or recode is elite status. We want to label them maybe based on the, we'll just give it the category name. So elite platinum dummy would have all the platinum, status. It's called elite status platinum. Platinum, customers in them and so on. So elite status platinum, and then we'll say all the new values and specify here the old value if it is platinum. Important to make sure you spell this correctly and have the right case. If the old value in elite purpose is platinum, then the new value for the dummy variable is going to be 1. Otherwise, all other values would be 0. Okay. This will create a new column for us called elite platinum. Let's take a look at that. You'll notice here we have a new row here called elite status platinum in the variable view. In data view, you'll notice we have we have a new variable here called elite status platinum that looks like this. So 0 indicates that they're not platinum, and 1 means they are platinum. You can make that no and yes if you want to variable label. So what we'll do here is we'll go to values and specify here that 0 is no and 1 is yes. These are platinum. And decimals are required here, so we'll take those away. Okay. I'll repeat this process for our other categories. Do this a little faster now. You get the idea. So gold, we'll have to say change all the new values, and we'll modify this to say gold instead of platinum. That should work. Repeating this for silver now. Value for silver become 1. Change. And okay, so now we can verify this all worked out once we assign these labels correctly. So I'll go and do this part. I'm going to copy this labeling part, value labeling part also, so we save ourselves some time on it. Notice we don't have a dummy variable for the no status group because we only need 3 dummies to represent 4 levels of a nominal scale variable. Now, okay, so let's verify this worked out correctly. We'll go to frequencies, we'll move in the variables we created over to the right, and hit OK. If you look at this, we have here the gold status is 20.3%. Well, we have for gold, we have here 20.3% for the dummy variable. For platinum, we have 9.9% in the original lead status variable. In our dummy variable, we have 9.9% ones. Lastly, for silver, we have 33.6 out here in our lead status variable, and in our dummy variable, we also have the same 33.6%. Okay. Having done this now, I'm sorry, you couldn't see that. I didn't share my screen with you. Let me do that one more time. So here's what I was talking about when you couldn't see the screen, the wrong screen shared. If you look in the output window now, we have an output here indicating gold status is 20.3%. Well, in our dummy variable, we have also 20.3% ones, or those that are gold. Same for platinum, 9.9. Lastly, silver, 33.6, and we have the same in our dummy variable. Note, of course, that these 3 variables here refer to our 3 dummy variables, and this is the original variable. All right, so at this point, we have finished our dummy coding. Here's what we have as far as our data is concerned. Now, I'm not going to go ahead and do the same thing for visit purpose, but we could do that for visit purpose as well if we were going to use that in a regression model, right? So visit purpose could not be used in its native form, would have to be converted to a dummy coded variables in order to be used for regression. Another important thing to point out here is now that we have dummy coded elite status, dummy coded this variable, we're not going to use this variable anymore in any regression. The reason we even coded that variable was so we would get the dummies out of it. The dummies are able to fully represent the information in elite status. We no longer need the elite status variable. Let's move back to our data then. Here we are. The question is, does any variable need to be dummy coded? Indeed, every nominal scale variable needs to be dummy coded. And we have done that. Moving along then, we're now looking at a simple exercise we're going to do here. Now, we've already gone over in a prior video of how to run a correlation. So now I'm going to move along, assuming you already know how to run the steps involved there. And we'll look at sort of like we'll kind of move along and just go and run the correlations without talking about the elementary, more preliminary steps in setting up a correlation. The first question here is to examine relationships among satisfaction with items related to cleaning. In our data, you'll notice we have a number of variables that pertain to certain kinds of satisfaction. So one such category is that for cleaning. So there are questions here. People are asked about satisfaction with cleaning of room, cleaning of bath, and cleaning of common area. I'm curious, I'm just wondering, is it that people who are happy with the room being clean are also happy with the bath being clean and are also happy with the common area being cleaned? In other words, are all these satisfaction with cleaning variables somehow correlated with each other? Now, correlation is a measure of linear association between a pair of variables. So we're going to examine correlation between every pair in this group of 3 cleaning variables. To do that, we're going to analyze, correlate, bivariate. And now we'll move the variables about cleaning over to the right. When you hit OK, you'll get an output containing correlations. So it turns out in this more recent version of SPSS, we have the option to show only the lower triangle. So if I check that box and say uncheck the box for show diagonal, it'll remove some of the redundancy I alluded to in a previous prior video. So if I hit OK now, we'll get an output looks like this. It's a simpler table, and it's again it hides from us a lot of the other garbage we don't want to see in correlation. So I'm sorry you couldn't see that, but here we are. In the upper window, here we have the correlations being run, and you can see them. Let's examine each one of them now. We have here correlation between clean bath and clean room. It turns out this is a very high correlation that, and what I mean by high is the number looks high. So a zero correlation would indicate no relationship, negative, an inverse relationship, positive, a direct relationship. So we're seeing out here that people who are satisfied with the bathroom being clean are also satisfied with the room being cleaned. The correlation is 0.464. That number is statistically significant because corresponding p-value is less than 0.05. In other words, these two variables are correlated. The correlation itself is a moderate size correlation. With regard to clean bath and clean common area, the correlation is slightly less at 0.26. That number, however, is still statistically significant. So is the correlation between common area and clean room. So we're seeing sort of like all the different satisfaction variables about cleaning are related to each other. Importantly, those who think the bath is clean are quite likely to also think the room is clean or be happy with the room cleanliness also. But common area seems like a different animal because that correlation is weaker. It's in the weak group because it's below 0.3. Okay. Let's go on and take a look at another exercise we can conduct out here. Let's examine relationships among satisfaction variables with items related to price. Specifically, let's examine how correlated satisfaction with room price, dining price, Wi-Fi price, and parking price are. So people often talk about a halo effect, which is when one thinks of, one thing, being sort of like halo for everything else. So you can think about people who have a certain view on price will feel the same way about everything else to do with price. We have here 4 price variable satisfaction measures. The question then is, or the intuition here is that maybe people who view the room as expensive and therefore unhappy with the price would also be happy with the dining price, Wi-Fi, parking. Or maybe they're different animals. That is, people who are happy with one, may or may not be happy with the other. Let's find out. Specifically, we're examining a number of bivariate correlations. We're examining correlation with, amongst 4 variables. If you think about permutations out here, that would mean we would have 4 times 4 C chooses 4C2, which would be 4 times 3 divided by 2. We'd have basically 6 possible pairwise correlations to look at. Analyze, correlate, bivariate. And now let's get these old variables out of here. We'll move the variables for room price, dining price, Wi-Fi price, and parking price into the right. As we had before, I'm going to only show the lower triangle. It's simpler and clearer. Here's our output. We can see out here that as far as these variables are concerned, our results are not indicating a halo effect. You like one, you like them all. you hate one, you hate them all type thing. Specifically, focusing here on correlation of room price and dining price. Well, the correlation is not even statistically significant. You see out here the correlation is 0.044, which means that those who are happy with the room price may or may not be happy with the dining price. It's not a given that they would, like one like the other. With regard to room price and Wi-Fi price, there is, however, a significant correlation. The fact that the number is 0.323 is telling me it is a moderate size correlation. Now, looking at parking price and room price, it seems like those who are happy with room price are also happy with parking price. However, that correlation is not as strong as that between room and Wi-Fi. Room and parking only have a weak correlation between them. Moving on to the next column, those who are happy with dining price are also happy with Wi-Fi price. Again, the correlation is statistically significant, but weak. Here's an interesting one. Those who are happy with dining price are very happy with parking price. I say very because, again, that correlation is 0.419 is statistically significant. The fact that it's 0.419 means it's a moderate size correlation. Lastly, Wi-Fi price and parking price have a significant correlation between them. All in all, we're finding out here that except for one non-significant correlation, all the different correlations out here are statistically significant. That is, you're looking at sort of like some type of price halo effect. You like one, you like them all, hate one, hate them all. But the one exception is room price and dining price. That correlation is not there at all. It might be worth, the hotel's while for the hotel to dig deeper into seeing why there's a breakdown here between room price and dining price by way of correlations. Okay, let's move along now and examine. We have so far examined a couple of different correlations. We have learned that you can examine variables or correlations not just in a one pair at a time, but you can put them all in one big correlation matrix, focus on maybe the lower half of the matrix only, and look at all of them in one single output view. Let's move along now and conduct and examine another sort of exercise here. So we're going to look at here whether satisfaction with aspects of experience have an influence on overall satisfaction. You've already seen in the data set, we have the hotel measures satisfaction across a whole bunch of aspects on dining price, Wi-Fi price, cleaning room, and so on and so forth. One question that many folks who gather our survey data is, well, which of them is most tied to satisfaction? Specifically, maybe the hotel finds out that some things matter to other people, other things don't matter as much. Maybe they find out that the dining room price has no bearing on the overall satisfaction with the hotel experience. So what we're going to do here is take a look at all these different satisfaction aspects and tie them to overall satisfaction. Specifically, we'll look at a multiple regression that is going to link overall satisfaction as dependent variable to all the satisfaction variables with aspects of experience. Let's go on to our data set here. We're going to look at here in this analysis the relationship of all these satisfaction variables with the SAT overall variable. All the variables we're looking at are all metric, so they're all appropriate for linear regression. We're going to analyze linear regression, linear. Here I'm going to move overall satisfaction to the dependent block and move all the other satisfaction variables from cleaning room to SAT recognition over to independence. And I'm also going to ask for a measure of multi-collinearity. The reason I even checked the box for multi-collinearity was because I'm a bit concerned when you have a lot of variables going into a regression, you're frequently concerned that there might be some interplay amongst the independent variables. We already know that if there's too much of a relationship amongst the independent variables, we might have a threat of high multi-collinearity, which might cause some problems in interpretation. Hit OK, and let's examine the output here. So our output is showing us that we have basically constructed a model, a regression model, with overall satisfaction as dependent variable and a whole bunch of variables as independent. The model R squared is at 0.329. We also have, we can then interpret this R squared to see if the R squared is, significantly greater than 0. And that's basically trying to find out if the satisfaction variables taken together or collectively have a influence on overall satisfaction. The answer to that is a yes, because our F statistic is a large number. And more importantly, the p-value it translates to is less than 0.05, telling us that, overall or collectively, all these satisfaction variables have an influence on overall satisfaction. You kind of expected that, but we've got validation now. Let's move along and examine now the size of the R squared. The size of the R squared is 0.329, meaning this is a moderate sized R squared. This is in that 0.1 to 0.5 range. Moving along, let's look at this big coefficients table. It's a large table because we have a lot of predictors here. Let's go through now, step by step, and examine every single one of these variables. So as you can tell, or as you would imagine, for every one of these coefficients or independent variables, we would typically construct a hypothesis to examine every single variable's effect on overall satisfaction. The first one here is clean room. And for clean room, you go along the clean room row, you'll notice the p-value is less than 0.05. For clean bath, our p-value is 0.051. Now, that's awfully close to 0.05. But remember, our rule is our p-value must be less than 0.05 for us to reject a null hypothesis and deem a effect statistically significant. This is a hard, it's a strong rule. Once you set a rule that it must be below 0.05, it must be below 0.05. There's no compromising once you've set an alpha 0.05. You must then stick to it. So you wouldn't look at a 0.051 and say, well, let me round that to 0.050, and then that's kind of 0.050, it's okay. No, it's not okay. So clean bath is not significant. Clean common area is not statistically significant either. Front desk staff, significant. Dining staff, not significant. Housekeeping staff, significant. And valet staff is not significant. Elite perks is. Room price is not statistically significant or related to overall satisfaction. Interesting. Dining price is. Wi-Fi price is not. Parking price is. City location is. Distance from transportation is not. Distance from events is not. Hotel points is. Okay. So before making too much out of this, let me just take a look at our VIFs. The VIF are measures of multi-collinearity. They tell us that if you were to, they'll tell us whether two variables, there's they'll tell us whether it's multi-collinearity. Specifically, when you have many independent variables in a model, it's quite likely that some variables are related to another variable, an independent variable. What this does is it tends to make the standard errors blow up, as a result of which a variable that would have otherwise been a significant predictor becomes non-significant. You could have two predictors that were very strong influencers on their own, but when you put them together, it sort of cancel out each other's effect. A nice analogy I like to use is that of if you take, think of regression as a game of football, American football, and you've got two of the best quarterbacks in the world on the team. Their effect on the game, as far as regression is concerned, would be non-significant. This is because the two quarterbacks perform the same role and thus make the same contribution to the game. In a regression model, their effects would pretty much cancel out because of extreme multi-collinearity. Both would be rendered non-significant, and you get a nonsensical conclusion. This is why we are usually concerned about BI if we want to make sure our multi-collinearity is not out of hand. Okay, one solution to dealing with extreme multi-collinearity is hand-picking the variables that go into the model. Another method we'll talk about later is using an automatic variable selection method that will automatically pick for you the good variables to go into the model. Okay, our takeaway then from looking at this is our VIFs are not too high, so I'm not going to worry too much about these VIF numbers. Yes, some numbers are trending to be higher, like you're looking at the numbers like this 2.761 looks kind of larger than the others, but for the most part, they're all under 5. So we have, small amounts of multi-collinearity here. I'm not going to worry about that. It's not a deal breaker for our model. Okay, so to conclude then, we have here found out that of the different predictors in our model, the things that matter, the things that drive overall satisfaction are satisfaction with room cleanliness, satisfaction with front desk staff. Let me circle these or mark these. Satisfaction with this matters. Front desk staff satisfaction matters. Satisfaction with housekeeping staff matters. Satisfaction with the Elite Perks program is important. Satisfaction with dining price is important. Satisfaction with city location is important. And satisfaction with hotel points is important. So these 7 variables have a significant influence on overall satisfaction. The takeaway for the hotel would be, if you want to maximize overall satisfaction, make sure people are happy with the room, front desk staff, housekeeping staff, elite perks, dining price, city, and hotel points. The others are not, they don't matter, at least not in a statistically significant way. Often the question comes down to, it's good to know these 7 variables matter, but of these 7, which is the most important or predictive of overall satisfaction? It is tempting to look at the unstandardized coefficients and draw that inference. This would be wrong and incorrect. You don't want to look at the unstandardized coefficients, draw the inference, because that is affected by scale of the variable. And by scale, I mean looking not just as was it measured in a 1 to 7 scale or 1 to 5 scale. Well, that's what we're concerned about here is, what about the standard deviation of the variable? Does the variable typically bounce around a certain range? And so we account for that variation in the variable to scale them. And we scale unstandardized regression coefficients by standardizing them. And these standardized coefficients are what you should look at in deciding what variable is most important in predicting the outcome variable. In this list, we see here of the standardized regression coefficients, the biggest one appears to be, as I look through here, the one for front desk staff. Let's give it number 1 then. And our number 2 is going to be a lot of numbers out here. I hope I don't group this up and okay. Second, number 2 seems to be, if I didn't make a mistake here, is clean room. Number 3 is elite perks. It seems to be elite perks. And number 4 is number 4 is dining price, and number 5 is number 5 would be city. Number 6 would be hotel points. Number 7 would be housekeeping staff. Number 8 would be, I know, you're thinking number 8, and you're jumping up to find me number 8 in this list, but guess what? There isn't a number 8, or number 9, or number 10, because we only have 7 significant variables. We're not going to look at relative importance of variable that is not deemed to be statistically significant. So of the predictors that are the most influential on overall satisfaction, these are the 7, and that's the pecking order on screen. The bigger the standardized coefficient, the stronger the influence on the overall satisfaction. Now, in deciding on the size of the effect, we are going to focus on the magnitude of the standardized coefficient. So we're not concerned about the sign. Is it plus or minus? If, for example, we had some variable at minus 0.3 for standardized coefficient, we would deem that as the most important predictor of overall satisfaction. Even though the sign is negative, when deciding an importance, you ignore the sign or valence. You only focus on the absolute size of the variable. Okay, great. So we have now gone through the process here and identified and interpreted a multiple regression equation with a number of variables. Let's take a look at another exercise. You can fill these out on your own because you know the process now. Okay, let's move on to looking at 2 more exercises before we end here. We'll look at the effect of elite status on overall satisfaction. Okay. Let's go to Spss again. We're looking to see if elite status is influential on overall satisfaction. So our variables to focus on are overall satisfaction and elite status. You might be in a hurry to go in and quickly run elite status as independent variable and stat overall as dependent variable. But of course, you know not to do that because elite status is nominal scale. And just to be clear, just because the variable is string is not the reason it is nominal scale. It is nominal scale because the levels of elite status are different categories. A variable like zip code, gender, ethnicity, religion, university they went to school for, so on. They're all nominal scaled variables. Okay. You could code them as being 1, 2, 3, 4, 5, but coding it as 1, 2, 3, 4, 5 wouldn't make ethnicity, for example, to become a scale variable. It would still remain nominal scale variable. So in our case, we have elite status is having 4 levels. platinum, gold, silver. We dummy coded them as being elite status, platinum, gold, silver. So we're only going to be using those variables in our regression. Analyze, regression, linear. I'm going to clear this whole window and start afresh with overall satisfaction as dependent variable and our three least status variables as being independent variables. These are our dummy variables. I'll also ask for the VIF. Click OK. Now, our results look as follows. We have here an output table with an R squared of 0.121 telling me that this is a regression where the three or elite status has a significant influence on overall satisfaction. So it matters in terms of evaluation of overall satisfaction whether somebody's platinum or gold, silver, so on. We don't know which one matters. We know jointly there's an effect. We also know that this effect or this model as such is a moderate effect size model because that number is between 0.1 and 0.5. Moving along to our next table. This table is key. We have here our coefficients table, and here we can learn very quickly by looking at the VIFs that there really isn't much of multi-collinearity to worry about. That's good. Let's focus on the crux of this output. So we have here the variables platinum, gold, and silver. We can see out here, in terms of overall satisfaction, platinum status is significant, gold is significant, silver is significant. In other words, all three of our different elite status clubs are significant predictors of overall satisfaction. That's good. But what does it mean for platinum status to be a significant predictor of overall satisfaction? Well, to understand that, you've got to think back to the meaning of a dummy variable. Specifically, what does it mean for status to be platinum? What is platinum being compared to? Well, when platinum status is significant, we're comparing platinum to everybody else. So those who have platinum status have sort of like excuse me. The platinum status variable is comparing platinum to all the other those who don't have platinum. Basically, we're finding out those who have platinum status are, you know, their overall their satisfaction is really high. Same for gold. Gold is being compared to the groups that don't have gold. So compared to those with gold status versus don't have gold status, again, we're finding out, you know, a statistically significant result there. Finally, for silver, again, we're finding out if you look at silver, silver versus those who don't have silver, again, the satisfaction is significant. Okay, so right, the last thing that I focus on here is what does it mean for these different variables? Which of these status is most predictive of overall satisfaction? So in a relative sense, like which one has the strongest effect on overall satisfaction? Is it platinum? Is it gold? Is it silver? Well, it turns out it is platinum. So platinum has got the biggest. So you look at the standardized coefficients, platinum status is 0.339, gold is 0.254, and silver is 0.168. Okay. Right. And that is, I guess that pretty much sums up this section on elite status. Let's go on to our last problem here. We have one more problem to look at here. We examine the effect of SAT dining staff on SAT dining price, SAT overall, and elite status on average food spent per night. So our goal here is to look at the effect of these three variables, these four variables on elite status on average food spent per night. And so I'm speaking about this. Let me think out loud here about a little a segue here. Let me go back to our data set. It just occurred to me as I look at the results out here. You know, it might be interesting here to construct another variable out here, which would be simply comparing those who have an elite status versus those who don't have an elite status. Right? So in our data, we have 4 groups for elite status. Let's take a look at them again. These are gold, no status, platinum, and silver. What if we decided to look at just those who have no status versus status? To do this, let me construct another variable. We'll create another dummy variable here, which would be whether somebody has status or not. We'll just call it elite status, and that's it. Elite status. Yes. And so if somebody has elite status, we'll say they're 1. No status. If they're no status group, if they're no status, let's spell that correctly, then this would be a no status. This would be a value 0. And if it's anything but no status, would be a 1. So the coding is here such that for elite status, yes, it's a dummy variable indicating whether somebody has elite status or not. So it's another a fourth dummy variable, a different dummy variable I'm trying to make out here that is simply has 2 values here, which would be kind of useful for us to think about as we look at the next analysis. Okay, so here is the summary of the variables so we can understand what these are. We'll move our new dummy variable over. So you can see out here from this output, what I've done is I've combined no status is still at 544. Let me do one more thing. Let me go back and label this variable so we can see this much better. And we'll say elite status members is the label of this one to distinguish it from elite status above. Right. Let's go back to our output now. Actually rerun the analysis and then go to the output. So the output window, here we have it now. So we have the labels that make this easy to understand now. So you can see out here that no status here is 544, and the same down here. Okay. So let's use this variable to predict overall satisfaction and see what we learn about regression and interpreting dummy variables. So I'm going to go here to analyze regression as before, and this time we'll only have this dummy variable in the model. Okay. All right. Here we are. We have an R squared here, 0.074, significant. Let's go past this one. Let's highlight these ones first. R squared is 0.074, and it's significant. Let's focus then on our coefficients table now and see what that means. All right, and our coefficients table is something that's worth spending a minute or so on. What does it mean? So our elite status members variable that we just created, a new dummy variable we created, has values 0 and 1. When this is equal to 1, right, that means that somebody has elite status. When it's a 0, they don't have elite status. What it thus means is that if you look at those with elite status, well, let's make an equation for this one, right? So we better understand this thing. So let me type out an equation in our slide. So let's examine the effects with elite status on overall status. This is a dummy reflect. As opposed to no status. So our equation of this regression would be as follows. We would have a regression that looks like 3.555 plus 0.648 times elite status. That's 3.555. So overall satisfaction is equal to 3.555 plus 0.648 times elite status. Okay. So what this means is, let's interpret this equation then. So again, elite status is, remember, is in this case two values, 0 or 1. When it is 1, somebody is either platinum, gold, or silver. When it's 0, the person has no status in the elite status system. So when elite status, when a person some status rating, overall satisfaction is equal to 3.555 plus 0.648 times 1. Okay. When a person has no status, overall satisfaction is equal to 3.555 plus 0.648 times 0. Therefore, the difference in overall satisfaction between someone who has status and doesn't have status is 0.648. Okay. This was the takeaway I wanted to highlight here then. Okay. So when you have a dummy variable, your regression coefficient is telling you, is reflecting in a sense the difference between the two groups of the dummy variable. In this case, 0.648, the regression coefficient is telling you the difference in overall satisfaction on average between those who have some status, platinum, gold, or silver, versus those who have no status. All right, so I'll just separate this. Okay, let's go on to our last exercise here, which is examine the effect of satisfying sat dining staff, sat dining price overall, and elite status on average food spend per night. So here we have all these different variables and average food spend per night. Okay. Let's run over to regression to SPSS again. we're going to focus here on average food spending per night. That's this variable here. Okay. That's our goal out here. So we're going to find the food-related satisfaction variables and lead status to predict whether somebody spends more or less dollars on food per night. Let's use the same dummy variable we utilized before. Let's compare. Let's use this one. Let's use our 3 dummy variables this time instead of the new one we created. All right. So our regressions, we analyze regression linear. We're going to go with, let's clear this off. We're interested in looking at average food spent per night on food. And our predictors are the satisfaction variables with relate to dining price, dining staff, dining price, overall satisfaction, and our 3 dummy variables for lead status. And I'll ask for the multi-collinearity statistics also. Click OK. Here we are. So our output looks as follows now. The R squared is kind of a very weak R squared, really. R squared is 0.011, telling us that it's small as such. But it doesn't really matter small. It's, sorry, you couldn't see the screen. Let me share my output window with you. I had shared earlier. Okay. So here's our output, and you can see now in our output that our R squared is 0.011. The corresponding F statistic and the p-value indicate, even though a small number in absolute sense, it is statistically significant. This is the p-value is less than 0.05. Okay. The R squared as such is telling us that this is a very weak model, that these variables together don't predict much variance in, or explain much variance in average dollars spent on food per night. Let's go on to the coefficients table. All our VI values are acceptable numbers. They're all below 5. Let's focus then on what things matter, what things don't matter. Okay. So dining staff, not significant. Dining price, significant. Overall satisfaction, platinum status, gold status, silver status, all non-significant. In other words, what we found out here is the only thing that influences the average dollars spent on food per night is satisfaction with the dining price. And taking this one step further, you'll notice here, in terms of interpretation, this number here for dining price, regression coefficient is positive, telling me the more satisfied people are with the dining price, the more dollars they spend on food per night. Okay? So if the price is right, they'll spend more on food, but nothing else matters. The dining staff doesn't matter. Overall satisfaction, platinum, gold, silver, nothing else matters. The implication for the restaurant is, a hotel is, if you really want people to spend more on food per night, make sure they're happy with the price. Intuitively, I would say, if the price is lower, people will be happier to spend more money. So what we've arrived at is a very trivial solution then, which is basically that offer people a good price for food, and they will spend more on food per night. But conversely, we've also found out that overall satisfaction in the hotel doesn't really affect how much they spend on food, nor does satisfaction with the dining staff have an effect on how much they spend on food, nor does their elite status. Okay, great. So in this example, we took a look at we looked at the hotel satisfaction data. to construct a number of correlations and regressions to get a better sense of what makes a difference for overall satisfaction with the hotel, and also what would make somebody spend more money on food per night at the restaurant. We also understood how to interpret dummy variables in a regression. Thank you.